I'm going to do a quick experiment showing you component 3, part 1, and this is an experiment, I think it's from February 2019, and I'm going to talk you through the apparatus quickly and then demonstrate the process. So what we have is a pad which has an abrasive side and a non-abrasive side. We have a Newton meter. There's two different versions of a Newton meter there. And we have a series of masses. These are 100 gram masses. You might use other sorts. And what we're going to do is we're going to conduct the experiment using our Newton meter and record the results and see what changes we get over a period of time. Okay, so I'm going to do this reasonably quickly. You might have a slightly different Newton meter. This one actually has quite a large scale. It goes up to 3 kilograms of weight there. You might find that you're given one which has an easier to read scale. But from my point of view, this is just me having to conduct the experiment, get a set of data. I'm not going to interpret that data. I'm just going to literally record it so that if you don't have this material or equipment available to you because you're not in school or you want to practice it, you can use this data set. Obviously, when you conduct your own experiment, I would expect there to be some change from that because the board that you're working on or the bench that you're working on, the abrasive material that you've got is probably slightly different to what I'm using here. So you wouldn't necessarily expect to get exactly the same results as I'm getting. So I'm going to conduct that experiment and record the results as I go. My Newton meter has been zeroed. Because of the viewpoint that you have from the camera, you might struggle to read it from the same position as I do, but we will give it the best we can. So I lock that onto my non-abrasive side to the table first of all, and I'm going to do that with zero mass. Make sure it's on nothing, and then in order to begin to pull that to move zero mass requires I'm going to read this in grams because it's simpler, requires 50 grams of force to get it moving. Okay, if I was to give that a steady pull, I've got 50 grams of force. Okay, now obviously 50 grams of force, you're probably going to want to work in newtons or grams. Either way, you're looking at your data and you can convert it afterwards. This is an easier scale in increments of 50 grams. It's up to you. Right, so 100 gram mass goes onto our load carrier, as we're calling it, and then I'm going to draw that along, and that's taking me to 2 increments, which is 100 grams. And that was a 100 gram mass. So I'm going to put another mass on, which is going to give us 200 grams. And if I now look at that, I've got 1, 2, 3 increments. So I'm looking at a force of 150 grams to pull 100 grams. If we had a further 100 gram mass, we're now looking at 3.5 increments. So we're looking at about 175. So we've got 50, 100, 150. I'm going to say 175 grams. Let's go to 400 grams by adding a further mass. Hopefully you can see that still. So to make that move steadily, I'm on 4 increments. So we're looking at 200 grams. I'm going to add a further mass. Make sure we're zeroed. Make sure we're straight. Okay. Okay, now in this case that's taking 250 grams. So I've now got 1, 2, 3, 4, 5, 6 masses. That's 600 grams. It's taking 250 plus one more increment. We're looking at 300 grams to pull 600 grams. Okay, I'm going to just draw that back a little bit so that you can see it on the camera. Okay, we'll add a further mass. So we're looking at 700 grams. Okay, so we're zeroed when there's no pulling force. Okay, I'm going to just draw that back. Okay, so a steady push is giving me, in this case, let's repeat that, 250 plus 2 increments. It's a bit variable there. Okay, so let's fix on that. 250 plus 2 increments is going to give me 350 grams. 350 grams. Let's add a further increment, a further mass added now. Okay, I'm going to just straighten up the apparatus, make sure I'm zeroed again. Make sure I've got a steady movement. So we're looking at 350, probably 400 grams at 800. So we're now adding 900 grams to that. Draw it back a little bit. Okay, I think I'm going to do that again a couple of times just to make sure I'm getting a okay. So I'm getting 900 grams. At that point, it's still requiring 400 grams. And then finally, the last mass, I'm going to just put that all on the hanger. Okay, so draw it back, and now I'm going to pull it forwards, and we're looking at that looks to me like a steady pull at 450, maybe 475. I'm just making sure that I'm reading this right as I'm doing this experiment. Jerky movements are going to result in inaccurate results, so I'm just trying to go sort of steady. I think we're looking at 450 to pull 1,000 grams. Okay, so that's the end of the non-abrasive test. Now what we're going to do is we're going to flip over the abrasive load carrier. Just taking those masses off. It would be much more sensible if I started with 100 grams. Okay, so that's what I'll do this time. I'm going to flip it over, so this time we've got the abrasive onto the board. Apart from that, everything is exactly the same. And we're going to start with our mass hanger on there in the middle. And this is the abrasive. And then we have the mass and the force. Now, you're actually given in the exam paper 200 grams on the abrasive side gave me a 200 gram pulling force to make it move. I've now put a third mass on, which makes it 300 grams. And if I pull that, that's giving me a force of 250, potentially 275, but I'm going to write it as 250 grams of pulling force. Okay, I'm now going to add a fourth slotted mass, so we have 400 grams, and make sure I'm zeroed and pull it. So we're looking at 250 grams to make it move, so 400 grams. I'll just take that back and run that again. Yeah, steady movement there is 250 is 300 grams. Let's go to 500 grams. I'm going to just take that back, so we're back in our alignment. Make sure we're zeroed. Steady pull. I'm going to do this a couple of times. So I'm looking at 250 plus 2 increments. So we're looking at 300, 350 grams. Then we're on to 6 slotted masses. 1, 2, 3, 4, 5, 6. Make sure we're on 0. Bring it back so you can see it. And draw it along. So it does seem to depend. The reason that I'm pulling this a couple of times, it does seem to depend on where I am on this workbench. So I'm drawing it steadily along. And I'm looking at, I think, 1 increment under 500 grams as I pull it. One more time. So at the point when it slows it down the most, we're looking at 450. 400, 450. I'm going to call that 425 grams. I'm struggling to pick up the specific difference there. So 600 grams requires a pulling force of 425 grams. Okay, now again, when you're evaluating your experiment, you might want to make a judgment call on that. I'm just looking at my surface underneath here, looking at what I'm conducting my experiment on. Right, so I've now got 1, 2, 3, 4, 5, 6, 700 gram masses. And I'm going to draw that along. So at this point, 700 grams, it was 350 grams to make it move. So if I now pull that along. Okay. See, again, there's not much difference in that. I'm going to just brush my surface down. Set myself up again. Okay, so I haven't added any slotted masses. 1, 2, 3, 4, 5, 6, 7. 0 R. Newton meter, pull it. At maximum pull, I'm still not seeing any difference there, which is interesting. Let's add a further slotted mass. Okay. Just make sure we're sitting on 0 there. Okay, so this is 800 grams. Going to draw that along. That again. So at that point, I'm looking at 450. I'm going to take that as my highest. 450 grams. Now again, I'm not going to interpret results. I can see all sorts of reasons why my data may be showing me a bit of a stall there. But that's your job to work out why that might be. Okay, so I'm going to add a further slotted mass. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're now looking at 900 grams. And draw that along. And we're looking at 500 grams to move that. And then our final measurement, take that back so that you can see it. Final measurement is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 1,000 grams, 1 kilogram, and we'll draw that along. Let's see what we get. Okay, so we're looking at 500. Yeah, 500 grams steadily. I'll pull that back and run it again. $500 grams. Yeah, it's at most 500 grams, the data on here. Okay, so if I pull it, I'm certainly not getting any more out of that. So 500 grams. So interestingly, there's no difference there between pulling 900 grams. But if you look now, that measurement is actually giving me at that, oh no, I'm back to 500. So, just out of interest, you know, you might want to think about what your data is going to tell you when you're working on your particular surfaces. Not all of the numbers that I've achieved on my data table are giving me what I might expect. But maybe if I was to repeat that experiment and get a similar set of data, I might start to give reasons why that was the case. But for now, hopefully that gives you plenty to think about, and the data is there for you to transfer into your own tables, and also you might want to be converting your 50 grams into newtons. So if you look at it, we've got 250 grams equals 2.5 newtons. Okay, 500 grams equals 5 newtons of force. So that's down to you to graph that, to record your results, to think about whether when you've watched me doing that experiment or when you're doing your own, whether there are any factors that influenced the set of data that you've got, whether anything could have been conducted better, and whether there were any errors in the data collection. Was the method right? Were the variables correct? Were they used accurately? This is your job now to respond to that, and hopefully your teachers will work through that with you and look at possible answers to to some of the queries that you've got there. So good luck with that. That's the component 3, part 1 test using an abrasive and non-abrasive load calendar. Have fun.